When we look at Earth from space, we see a perfect blue marble, but beneath the oceans and continents lies a restless shell, the lithosphere, that is anything but smooth and unbroken. Earth's crust is fractured into massive slabs of rock, known as tectonic plates, and these plates are in constant motion. Think of them like enormous rafts floating on top of a softer, molten layer beneath called the asthenosphere. This slow, creeping movement is driven by heat rising from Earth's core. Over millions of years, this circulation of heat pushes the plates around, making them grind against one another, collide, or drift apart. Where two plates collide, mountains can rise. The Himalayas, for instance, were born when India slammed into Asia. But when one plate is forced beneath another, something else happens. A trench forms. These aren't small cracks, they're colossal scars in Earth's crust, stretching thousands of kilometers and plunging to unimaginable depths. The Mariana Trench lies at one of these destructive plate boundaries. It exists because the Pacific Plate is relentlessly colliding with the smaller Philippine Plate. Over millions of years, the heavier Pacific Plate has been forced downward, carving a trench so massive that it is the deepest known point on Earth's surface. This is the first clue to understanding why the Mariana Trench is so deep. Earth itself is dynamic, alive with movement. Its surface is not a static landscape, but a battlefield of rock, heat, and time. The trench is not an accident. It is a consequence of Earth's restless nature. Every mountain, every ocean basin, every trench tells this same story. But among them all, the Mariana Trench is the most extreme, the deepest scar in Earth's endless cycle of creation and destruction. At the heart of the Mariana Trench lies a process as ancient as Earth itself: subduction. This is where the true depth of the trench is forged, where one titanic slab of Earth's crust dives beneath another in a slow-motion collision that has been happening for millions of years. Picture two giant conveyor belts meeting head-on. The heavier of the two is pulled downward, sinking into the fiery mantle below. In the Western Pacific, this is exactly what happens. The Pacific Plate, vast and ancient, is colliding with the much smaller Philippine Plate. The Pacific Plate is older, colder, and denser, and so it is forced to bend and plunge beneath its lighter neighbor. This bending creates a vast depression in the ocean floor, the trench itself. Over tens of millions of years, as the Pacific Plate continues its relentless descent, the trench grows deeper and sharper, like a scar being etched deeper into stone with each passing century. The Mariana Trench, then, is not just a hole in the ocean. It's the front line of a geological battle. Here, rock meets rock, pressure meets pressure, and the crust is torn downward into the depths of Earth's mantle. Without subduction, there would be no Mariana Trench. Mountains may rise where plates collide head-on, but it is this downward pull, the dragging of one plate beneath another, that carves the deepest scars on Earth. The Mariana Trench is the ultimate example of this destructive process, a reminder of the unimaginable power hidden beneath the calm blue surface of the Pacific Ocean. There are many trenches scattered across the ocean floor. The Peru-Chile Trench in South America, the Tonga Trench near New Zealand, the Philippine Trench. So why is the Mariana Trench the deepest of them all? What makes this place, above all others, plunge further than any other point on Earth? The answer lies in the unique nature of the Pacific Plate itself. Unlike younger oceanic plates, the Pacific Plate is one of the oldest in existence. Over time, oceanic plates cool as they move away from the fiery ridges where they were formed. This cooling makes them denser, heavier, and more likely to sink steeply when colliding with another plate. By the time the Pacific Plate reaches the Mariana region, it is ancient, over 170 million years old. Its weight makes it sink at a sharper angle beneath the Philippine Plate, dragging the ocean floor down with it and carving out a trench of record-breaking depth. But there's another factor: the Pacific Ocean itself. It is the largest and deepest of Earth's oceans, giving this tectonic collision the perfect conditions to create an extreme subduction zone. Smaller oceans simply cannot generate the same scale of downward force. So the Mariana Trench is not just deep by chance, It is the result of a perfect geological storm, an ancient, heavy plate colliding at the right angle, in the right ocean against the right neighbor. The outcome is Challenger Deep, the single deepest point on the planet's surface. The trench's depth is, in essence, a reflection of Earth's history. It tells the story of an ancient plate that has carried the weight of time itself, sinking relentlessly into the abyss. When we imagine the Mariana Trench, we often think of it as a smooth, simple valley on the ocean floor. In reality, it is far more dramatic. A twisted, jagged chasm that looks more like the scar of some ancient wound than a neat geological feature. The trench stretches nearly 2,500 kilometers long and up to 70 kilometers wide. Its walls drop down like cliffs, plunging almost vertically into the abyss. At its deepest point, Challenger Deep, the seafloor lies nearly 11,000 meters below the surface. To put this in perspective, that's deeper than commercial airliners fly high. The shape of the trench is sculpted not only by subduction, but also by earthquakes and landslides that occur within its walls. Each time the Pacific plate grinds a little deeper beneath the Philippine plate, the trench shifts, cracks, and reshapes itself. Some parts are narrow and sharp, others wide and sloping, creating a landscape more alien than anything on land. And then there's the pressure. At the very bottom of Challenger Deep, pressure is over 1,000 times greater than what we feel at sea level. It is so intense that if you tried to stand there without protection, your body would be crushed instantly. Even steel-hulled submarines risk imploding under such force. The Mariana Trench is not just the deepest, it is the most extreme environment on Earth. Its shape reflects the violence of tectonic activity, a living scar that shifts and changes with each geological heartbeat of the planet. To journey here is to visit the very edge of the possible. Despite its crushing depths, the Mariana Trench is not lifeless. In fact, it is home to some of the most extraordinary creatures on Earth, organisms so bizarre and resilient that they defy our very understanding of life. Among them are amphipods, shrimp-like creatures that thrive under pressure that would crush almost any other form of life. They have adapted cell membranes and proteins that prevent them from collapsing, allowing them to swim freely in the abyss. Then there are the snailfish, translucent, ghostly animals that live deeper than any other known fish, gliding through darkness where no sunlight has ever reached. Even more remarkable are the microbial communities that exist here. These microscopic lifeforms survive by feeding not on sunlight, but on the chemical energy released from minerals within the seafloor. They represent an entirely different way of living. Life fueled not by the sun, but by Earth itself. Scientists study these trench dwellers not only for their own sake, but because they may hold the key to medical and technological breakthroughs. Their unique adaptations to pressure could inspire new materials, medicines, and even insights into how life might exist on other planets and moons. The Mariana Trench is not just a geological feature. It is a living laboratory, a window into both Earth's past and its future. It shows us how life can survive in the most hostile conditions imaginable, and it challenges us to rethink what is possible. In the deepest darkness of our planet, life endures, and in that endurance lies one of the most profound truths of all. The mystery of the Mariana Trench is not only about why it is so deep, but also about how life has found a way to thrive in the very heart of the abyss.